This is plasma. After solid, liquid, and gas, plasma is the fourth state of matter. It is made of particles that have been ionized. This means the particles have been given so much energy that electrons separate from their atoms, making a subatomic soup. Unlike gas, plasma easily conducts electricity.
Dark lightning, presented by Science at NASA. So, in 2010, researchers were not surprised when the telescope was hit by a beam of high-energy positrons, the antimatter equivalent of electrons. That's the sort of thing Fermi is out there looking for. But they were surprised when they realized where the antimatter came from, not from some black hole light years across the galaxy, but rather from our own planet. The source was a thunderstorm just 3,000 miles away. Earth's magnetic field seems to have corralled about 100 trillion positrons from the storm into a tight beam and funneled them all the way to the spacecraft, explains lightning expert Joseph Dwyer of the Florida Institute of Technology. Something was producing antimatter above the clouds of Earth and hurling it into space at nearly the speed of light. But what? Dwyer and collaborators at the NASA Marshall Space Flight Center and the University of Alabama believe they have figured it out. The answer, says Dwyer, is dark lightning. Dark lightning may sound like an oxymoron, but there is growing evidence that it is real. Ordinary lightning happens when electric fields build up inside thunderclouds. Electrons rush from one part of the cloud to another to try to cancel out the growing voltage. The flash of light we see traces the path of the charged particles, which heat the air 5 times hotter than the sun. If Dwyer's ideas are correct, dark lightning is a competitor of ordinary lightning. It also tries to cancel out the thunderstorm's electric fields. The process, he says, goes something like this. Under the right conditions, electric fields in a thunderstorm can create a powerful avalanche of electrons, shooting upwards nearly as fast as light. The electrons collide with air molecules, in turn producing gamma rays. Earth-orbiting spacecraft have been observing gamma-ray flashes from thunderstorms since at least the mid-1990s. Next, the gamma-ray energy transforms into a pair of particles, an electron and a positron. Successive collisions between these particles and other air molecules create a new batch of positrons and electrons, and the cycle repeats. A continuous feedback loop forms, like nuclear fission. It's a natural, self-generated, self-sustained particle accelerator, says Dwyer. Once the feedback loop gets started, he says, it can discharge parts of a thundercloud as fast as lightning. And, because the cascading electrons and positrons generate more gamma rays than visible light, the whole process is practically invisible to the human eye. Researchers once thought that gamma-ray flashes from thunderstorms were a weird byproduct of ordinary lightning. Now they are thinking it is a sign of dark lightning instead.